If you've ever clicked a button on a website, scrolled through an app on your phone, or seen a cool animation pop up on your screen, chances are you've been interacting with JavaScript. It's pretty much the invisible engine that powers the modern interactive web. But how did a language that was, believe it or not, created in just 10 days become this absolute global standard? Well, let's get into it. Okay, first things first, let's clear up one of the oldest and most common mix-ups in the tech world. Despite the name, JavaScript has practically nothing to do with Java. Think of it like this. Java is for building big, standalone applications that need to be compiled before they can run. JavaScript, on the other hand, is a scripting language. It's just plain text that runs directly inside your web browser to make websites come alive. Two totally different tools for totally different jobs.
So here's our game plan for today. We're going to start with the fundamentals. What is JavaScript, really? Then we'll pop the hood and see how it actually works. After that, we'll explore the huge, sprawling world of tools built around it. And finally, we'll look ahead to what the future holds.
All right, let's dive into part one. What is JavaScript? Well, at its core, it's all about one thing: adding behavior to a web page. Here's the textbook definition, but what it really means is this. If a website does anything more than just show you static text and pictures, if it responds to your clicks, updates content on the fly, or plays a video, that's JavaScript doing the work. The best way to understand this is the layer cake analogy. You've got three main layers to any website. First, there's HTML, which is the skeleton, the structure, and the content. Then you have CSS, which is all the styling, the colors, the fonts, the layout. It makes it look good. And finally, you have JavaScript. That's the third, crucial layer that adds all the interactivity and brings the whole thing to life. And that interactivity covers a whole lot of ground. We're talking about everything from simple animations and controlling a video player to making sure you've entered a valid email address in a form. One of the biggest things it does is load new data without forcing a full-page reload. That's a technique called AJAX, and it's what makes modern web apps feel so snappy and responsive.
Now, the history here is pretty wild. The first version was famously written in just 10 days at Netscape back in '95. A couple years later, to make sure it worked the same everywhere, it was standardized as ECMAScript. But the real game changer? That came in 2009 with Node.js. All of a sudden, JavaScript could escape the browser and run on servers, which completely transformed it from a simple scripting language into a tool you could build entire applications with.
So we know what JavaScript is, but how does the code you write actually turn into something that happens on your screen? It's time to head into the engine room.
Every single web browser you use, Chrome, Firefox, Safari, has a JavaScript engine built right into it. This is the heart of the whole operation. You've probably heard of the big ones: Google's V8 engine, which is in Chrome and also powers Node.js, Firefox's SpiderMonkey, and Safari's JavaScript core. Their job is to take in JavaScript code and make it run.
And how do they do that? It's basically a three-step dance. First, the engine parses the code, which means it reads it and organizes it into a structure it can work with. Then comes the really clever part: just-in-time, or JIT, compilation. Right before the code is needed, the engine transforms it into super-fast, optimized machine code. Finally, that machine code gets executed by your computer's CPU.
Now, this brings us to a huge challenge. See, JavaScript is single-threaded. That means it can literally only do one thing at a time. So, how can it possibly handle long-running tasks like fetching data from a server without just freezing up the entire web page?
The solution is this really elegant idea called the event loop. Instead of getting stuck waiting for a task to finish, JavaScript just hands it off to the browser to deal with in the background. The event loop's job is to constantly check, hey, is the main thread busy? No? Okay. Did any of those background tasks finish? When one does, it brings the result back to be processed.
This is how all those pieces fit together. You've got the call stack, which just runs your code line by line. When it hits something that's going to take a while, it passes it over to the web APIs in the background. Once that task finishes, its function gets put into the callback queue. And the event loop, the hero of our story, is constantly watching. The second the call stack is empty, the event loop grabs the next thing from the queue and puts it on the stack to run. It's this system that makes JavaScript feel so fast and responsive.
Okay, we've gone deep inside the engine. Let's zoom way, way out. Because modern JavaScript isn't just a language anymore. It's a sprawling metropolis of tools, libraries, and frameworks. A huge part of that metropolis is frameworks. Think of these as massive toolkits of pre-written code. They give developers a starting point and ready-made solutions for common problems, so they don't have to reinvent the wheel every single time they build a big application. The big names you always hear are React, Angular, and Vue.
And just how popular are we talking? Well, look at this. According to the State of JS survey, React is used by a mind-blowing 91% of developers. Its popularity comes from its whole philosophy of building user interfaces out of small, reusable pieces called components. And of course, the fact that it's backed by Meta. React is an absolute giant in the field.
The other huge force in the modern ecosystem is TypeScript. Now, it's not a different language exactly. It's what's called a superset of JavaScript. It adds some powerful new features on top of regular JS, and then, when you're done, it compiles right back down into plain old JavaScript that any browser can understand.
So what's the big deal? It all comes down to when you find your mistakes. With regular JavaScript, you might not discover an error like trying to add a number to a piece of text until the code is actually running. TypeScript is different. It checks for those kinds of errors before you even run the code. For huge, complex projects, this is an absolute lifesaver.
And you can see its value in the adoption rates. This number really says it all. The latest Stack Overflow survey shows that nearly half of all professional developers are using TypeScript now. It's moved way past being a niche tool. It is rapidly becoming the industry standard.
So that's where we are today. But where is all of this headed? Let's take a look at the key trends that are going to shape what JavaScript looks like in the next few years.
There are 4 big ones to watch. First, this idea of framework agnosticism. Big companies like Spotify are building apps using something called micro frontends, where different parts of the same app can be built with different frameworks. Second, a huge focus on performance, using new technologies like WebAssembly to run really intensive calculations at top speed. Third, and this is a big one, AI-driven development. And finally, the trend we just talked about, TypeScript becoming the default choice for any serious project.
And that AI trend isn't some far-off future. It is happening right now. Projections for 2026 show that a majority of developers will already be using AI tools to help build things in their day-to-day work. Just think about that. In a couple of years, having an AI help you write code could be as normal as using a code editor.
And all of this leads us to a pretty profound question for the future. As AI starts writing more and more of the code, and our tools and frameworks become more interchangeable, what does the role of the human developer become? Is it less about writing individual lines and more about being the architect, the strategist, the one who directs all these powerful tools? It's definitely something to think about.
That's all for this explainer. Thanks for joining me.